Hey everyone, today we're gonna be doing a lead code question which is to find subarray product less than k. So we have a array of integer which contains some number. We need to find like which all number contributing and like creating a product of array which is strictly less than k. So we need to find like if it is an array, we need to find how many subarrays in them will have a product less than k. It's like in the question they are asking strictly less than k. So if you see in this example, like 10, 5 and 2 is creating 100, but we need strictly less than k. So we didn't include this 10, 5 and 2. So let's see the constant here. They are saying there can be minimum one element till 10 to the power 4 element at max. And same number can go till 1 to 1000. And k can go from 0 to 10 to the power 6. So let's see like how to do this with some example. If I take the first example itself, they told like array will be something. Let me see like what is array. Okay, so array is like 10, 5 and 2 and 6 and k is given 100. Okay, so this is some array. I have k which is 100. I need to find how many subarrays are there which is creating a product less than k. So product in terms means if I multiply this number with this number with this number with this number, it will be creating a product of array. So if I say, okay, let's product all of them. If I start from here, I'll take okay 10. Now again 5, it's like 50. Now my product is 50. I include 2, it become 100. So I need to find how many subarrays will have a product less than 100. So if I see the very brute force approach, what I can do, I can generate all the subarray. If I generate all the subarray, it will be looking something like this. If I say I'll start from 10, I'll say 10, 10 and 5, 10, 5 and 2, 10, 5, 2 and 6, it is a subarray. If I start from 5, I'll consider 5, 2. I'll consider 5, 2 and 6. It is a subarray. If I start from 2, I'll say 2 and 6. If I say start from 6, it is 2. 6, sorry. So if I started from here, I have one subarray with 10, another with 10 and 5, another with 10, 5, 2 and another with 10, 5, 2 and 6. So subarray means a continuous part of a array. I cannot have these 10 and 2 as a array, a subarray, because I need a continuous part of a array. So if I start from 10, I can have these many subarray. If I start from 5, or you can say this position, I can have these many subarray. If I start from this position, I can have this many. I start from here, I can have this many. So if I say you, there's a formula to generate all the subarray. If you wanted to know, so we can say how many subarrays will be there with a complete array. So if you see, there's a formula like n into n plus 1 by 2. So this denote like how many number of subarrays we can generate with this array. So if I generate all of them, like I might be using two loops. One I will be iterating over this array and I will be iterating next to all. Like I have some like for loop I 1 to n. Another I have like for j from I to n. Okay, so I will be like creating a subarray with this element and I will be storing that to somewhere. So if I say the time complexity for like iterating or creating a subarray will be order of n square. Same for the space complexity because we will be storing all those subarray. But if you remember, like in a constant, they told like number can go 10 to the power, like at max they can go 10 to the power 4, 3 into 10 to the power 4. So if I say it, if I use two loops, it will be creating 10 to the power 8 operations. But in CPU cycle, you can do 10 to the power 7, you can say operation at a time. So we cannot use nested loop, or you can say we cannot use this approach to generate all the subarray. So my approach one to generate all subarray didn't work here because it is taking n square time complexity. I need to optimize somewhat. So my approach two will be like I will be iterating over the array, but I will not be iterating twice over the array. So I need to do somewhat like n log n, or I need to do something around n if I need to optimize from n square. So let's see like how to do this in an optimized way. If I write this array again, 10, 5, 2 and 6. So let me introduce to one new concept, like it's not a new, but we are doing it first time. So we have a concept of like two pointers in an array. two pointers means I will be having two start, or and you can say I will be having two indexes stored in my array on value. I will be checking, I will be like looping with those two index. I might be having some left and right, or I might be having low and high, like we have done in a binary search. So either I can use binary search, it will be having an log n approach, and even I can use a normal two pointer approach. It will be having like 2 points, our left and right, denoting the position we are currently in. So what I will be doing, like I might be iterating over this array, and I will be like doing the product in place. So in the, like if I have my left here, if I say I have my left here and right here, so my product is what? 10. If I say okay, I'll say to right, go ahead and like increment your value and include the next value. So my product became what? 50, because I included these two. So my product is now this. And if you see, if I wanted to know how many element is contributing to this, I can say okay, there is a two element from left to right, there's some element. If I wanted the size, I can say okay, left minus right, I can say right minus left, which is like it is index 0, 1, 2 and 3. So if I say 1 minus 0 plus 1, it will be giving me the length. You can say this window. For first, this was the window. If I incremented my right, this was a window. If I increment my right again, this will be my window. If I increment, this will be my window. So I incremented my right, window became this much. Okay, this much. The product is 50 now. I increment my right again. Okay, now this is my current window, but the product became what? 100. I cannot have 100 as a product because they say strictly less than equals less than 100, or you can say strictly less than k. My product can be strictly less than k. So if I say okay, this is my restriction, product can have less than k as per our requirement. So I'll say okay, if this is the case, you need to decrement your product. So for that you need to increment my left value. I mean like I need to remove this particular case, so my product will be now much less because I have included this in my previous case. So I'll say okay, delete from here, increment. My window became this. I have these two elements. So I'll say now product became what? 10. So what we have done, like we have divided 100 by 10. My product became 10 now. I'll include my right again. Okay, I'll say increment my right pointer. My product now became what? 60. So it's fine still. So if you see in each scope, if you see here, I have 5, I have taken 10, I have taken 10, 5, I have taken 10, 5 and 2. If I say, okay, let it be, we have this size over here. I'll say there is some window. I'll mark. So what is this? Let's see how many of them are like giving the subarray equals to, or you can say less than k. So if I say for this one, this is a subarray size sum equals to 10, which is fine. This is 50, this is 100, this is 600, this is 5, this is 10, this is 60, this is 2, this is 12 and this is 6. So if I just count, this is a subarray less than k, okay fine. This is a subarray less than fine. So what I need to check, is this a less than 10 n is k or not? So okay, what I need to do, I need to count all of them. So one is this, one can be this, 100 cannot be there, 600 cannot be there, 5 can be there, 10 can be there, 60 can be there, 2, 12 and 6 can be there. So we have counted in such a way. Same what we'll do, I need to see how many of them will be creating doing the pair. So if I say at max 10 can be a 1 point, if I say 10 and 5 can be 1 point, or if I say if I'm like my current pointer, my right pointer at one position, let can tell me how many subarrays it can be there with this particular index, and the sum less than k. So if I say my right pointer is there and sum is less than k, so if I say this is my pointer, this is creating one subarray. So if I say if I am that 10th number, you can say 0th index, I have one subarray. If I include 5 as well, if I include 5 and 10, it is creating two subarrays. Or if I say include, if I am at 5th position, my subarray size is 2. This is my subarray size, and which will be like contributing two subarrays. One is this, one is this. Sorry, 10th will be creating one, 5 will be creating this, and this complete. So if I say, if I wanted to know all the subarray inside this which is contributing a product less than k, so 10 can be there, 5 can be there, and 10 and 5 can be there. We have included 10 already. We can be including 5 and 10. You can say 5 and 5, 10 using 5. Similarly, if I include 2, if this index, let me write the index, it will be much better. So 0, 1, 2, and 3. If I include 1, if I include 0th index, there can be one subarray. If I include the first index, there can be two subarray. These two, and this two. If I include the second index, there can be how many subarray? Because if I include all these, it will be creating 100 as a size. So I need to remove this. I can have at max 2 and 2, 5 as a subarray. So including second index, I can have two subarrays. If I include 6, or you can say third index, I can have 3 subarrays. So if I count all of them, it will be creating like 8, or it will be like total subarrays will be giving a product less than k. So let me write a code so you can get it much faster what I'm trying to say. So let me show the base case. So if we have k less than equals to 1, we need to return 0. Like there cannot be a case with k less than you can say size, you can say k equals to 0, k equals to 1. There cannot be a subarray because 0 cannot be a part because number is starting from 1, and they are saying there will be strictly less than, the product can be strictly less than equals to k, less than k. So if a number is starting from 1, it cannot be a part because we need something less than, strictly less than k. So number less than or equals to 1 will be like giving 0 as a count. Uh, Let me have a count first. Okay, so let me have a count and product. So these are my two variables I will be maintaining, and both will be like count will be 0, my product will be 1 initially. So 1 is like a neutral number, I can have anything multiplied by 1, it can be same. So if my base case is like k is less than equals to 1, I'll return my count here, or in simple word, I'm just returning 0 in this case. Now I need to maintain my left and right pointer. So I will be iterating left and right with value, like both will be starting from 0th index. I will be iterating till right is less than size. Now let me create a size as well. So size will be like what? Length of numbers. Okay, so this is a size. We can go till size at max. So what we need to do, if I write the skeleton alone, so I need to return our count at last. And each time when I'm iterating to the right will be incremented one position by default. Or you can say I'm just iterating over the array, so I need to like shift my right pointer. This is my base, or you can say structure. Now I need to consider a product. Like if I'm considering this particular number, the right number, or you can say I'm starting from this, I need to include this to my product now. So I will be placing my product, like I will be multiplying my current number, the right value to this product. And if my product become greater than, if my product become greater than or equals to what? K, I need to remove the left pointer. If I have considered these three, if I included right here, right here, right here, I need to remove the 10, which is the left index, the first index. What I need to do, I'll say, okay, product is a product divide by equals to the number at left index. So I'm just shifting my left and right to create a window. So I need to I'll again like I'll do left plus plus to shift my left window. It will be creating some window. At last, what? If I have a valid, you can say valid subarray, what I need to do, I need to say how many subarray will be like contributing in it. So I will be like doing something like count plus equals to something. I need to give a window. So this will be my window. What, how many element can be there in a window? So I'll say, okay, right minus left plus 1 will be giving me my current window. How many subarrays are contributing from it? So if I submit, or you can say if I run this case, let me check if the code is working fine or not. So this is working fine. Let me submit this code. Let's see if it is working fine or not. So it's, yeah, it's working fine. So yeah, that's all for today. I hope you got the concept of this right and left pointer in today's question. And yeah, that's all from today's question. Okay, thanks for watching.